Hey everybody, my name is Ben Grimico. I'm from InterNACHI. That's the International Association of Certified Home Inspectors. We train and certify home inspectors all over the world, and we also do webinars. And this is a free, live, online, interactive webinar. And sometimes I do the presentations. Those are the boring ones. If you can't sleep at night, you can do my classes. But sometimes the good ones are when we have an expert instructor. And today we do have that expert instructor. And his name is Eric Grubbs. We're going to do a webinar, and during this webinar, you can ask questions if you'd like, but it's going to be a 2-hour webinar. We've got a lot to go over. We're going to take a break in the middle of the 2-hour webinar, but feel free to ask questions on your side. There should be a Q&A button. There's also a chat button. I'm not going to pay attention too much to the chat. Do the Q&A. I kind of like that because you can upvote good questions. And I might interrupt Eric if that's okay with a good question. Maybe we'll save some at the end, but we've got a lot to go over. So let's get started. In this webinar, you're going to learn about HVAC systems and components, including gas furnaces, their categories, air conditioning systems, the heating and cooling cycles, characteristics of energy efficiencies, and a lot more. Again, a 2-hour webinar. If you're an InterNACHI member, at the end of the live webinar, for attending the live webinar, you can upload 2 hours of CE into your dashboard. Now, Eric Grubbs has more than 20 years of experience in the area of HVAC as the owner and operator of his own company, and as a field tech for industrial and commercial systems, and as an instructional designer for Train, and as a trainer, instructor, and sales rep for various companies. He's a graduate of the Community College of the Air Force. He holds 2 associate's degrees in mechanical and electrical technology and in military instructional technology, as well as an EPA 608 universal certification. Holy cow, Eric, that's a mouthful. I looked up 608. Those are for people who, that certification is a federal certification for folks who handle refrigerants and systems that could release refrigerants into the air. Isn't that right?
Yes, it is, Ben.
Wow, you've got the credentials like crazy, my man. So thank you so much, sir, for doing this. I really appreciate it. You're coming from kind of like an overlapping industry. Home inspectors, we inspect these systems and components, and you know all about them. And we really appreciate having an expert instructor come to our side and teach us more about these systems and components. So we really appreciate it. Thank you so much, Eric.
Yes, absolutely, Ben. I'll go ahead and share my screen.
Absolutely.
And we'll get into our PowerPoint presentation.
Yep. And while you're bringing that up, again, folks, if you're attending live, feel free to ask Eric some questions that you have. Use the Q&A feature if you'd like, and take it away, Eric.
All right, perfect. Thank you, Ben. And as Ben mentioned, so here's kind of a slide of a few of my credentials. Started out in the HVAC industry within the Air Force and got all my credentials, and then was sought after by many different manufacturers within the HVAC industry, to include Trane, Ream-Rude, and now I'm a technical trainer for Lennox, and still serving in the United States Air Force. So this is kind of my background, and what we'll do is kind of talk about what we're going to get into today, some of the hot topics that I put together for you guys, heating types and their categories. We're going to talk about venting on natural gas appliances, furnace sequence of operation, AC and heat pump systems, and AC sequence of operation. The more you guys know about how a system actually operates, it makes it a lot easier to understand if there actually is a problem when you guys are out there doing home inspections. So a couple of the objectives that I've kind of laid out for you guys. Explaining, by the end of this, you should be able to explain the sequence of operation on furnaces, identify different categories of gas furnaces, and describe AC and heat pump operations. So we'll get into the heating types and categories. First part of this is you have 3 different main types of heating appliances out there that you guys are going to be inspecting. You have the electric heat, you have a gas heat, and you have an oil-fired heating system typically. And here's kind of a diagram of just a cutout of all the bells and whistles within a furnace system, just kind of showing you locations of different components within that system and how the air comes in and how the air is conditioned and then supplied out to the home. So a few things that we definitely wanted to point out, especially as home inspectors, is when you're doing your inspections, you're going to have four main components that you're going to be kind of looking at. Definitely the controls, what type of controls, what's the location of those controls. For heating systems, you definitely want to understand what type of fuel supply, whether it's propane, natural gas, or oil. And if it's electric heat, then it's obviously going to be electric. Heating and cooling units, what type that you're going to be running into. That's why we're kind of going over the categories. And then also the distribution system, which is your ductwork, understanding how the importance of supply air affects these systems and the performance of the equipment. So I kind of have a little diagram here for you. So you're looking at your thermostats, identifying the fuel source, identifying the appliance, and then also your duct system. So for electric heat, a lot of times you're going to run into whether it's electric heat strips, baseboard electric heating, or if it's an air handler that uses a heat pump type, or maybe even a combination of heat pump using refrigeration as a heating method, along with some type of auxiliary heat strips. So these are just some of the things that you guys will be coming across. And the simplest form of checking a lot of this is really just turning it on, making sure that it is doing what it's supposed to do at your guys' level. When I teach this on for technicians, there's a lot more that goes into these and checking the accuracy of how these components actually operate. But for you guys, you don't have to go in as depth when you guys are doing home inspections on electric heat type furnaces. Gas furnaces, there's a couple of different types that you're going to run into. We'll get more in depth when we start talking about the categories, but the two main ones that you're going to notice is either going to be like an 80% furnace or a 90+% furnace. And if you come across really old homes with really old furnaces, you're going to be looking at the old styles that may be 60% or 70% type furnaces. They're no longer manufactured that way. And they do have the same capabilities of operation, the way that the 80% furnaces operate in a sense, but there are a few differences, and we'll point those out when we get to the categories. So with gas heating, we do have a heat exchanger. This is where your burner ports are going to basically send fire directly into the burner ports in a heat exchanger. And as those exhaust gases go through, it's going to heat up that heat exchanger, and that is where your heating is going to come from. Another type is oil-fired. These are more common northern areas of the country. Being here in Phoenix, Arizona, I don't typically run into any type of oil-fired system unless it's on the commercial or industrial side. But for residential, this would just be overkill for the location that I'm currently in. But a lot of you may have ran into oil-type heating systems that are out there. One big difference between an oil-fired and a natural gas type system or propane system is that it has its own burner that's completely separate from the unit. Even though it's mounted onto the unit, this component right here, the gun type burner, actually does everything internal and produces the flame. So it has the oil pump, it has its own centrifugal fan to pull in mixed air, and then it also has its own igniter to ignite the air fuel combination, and then produces a flame on that. So let's get into some of the categories that you guys deal with for oil and gas type heating systems. And what this really kind of boils down to is your flue, whether it's a negative pressure flue or positive pressure flue, whether it's condensing or non-condensing. A lot of times you should be able to just look at a system and be able to tell whether it falls under a Cat 1 or a Cat 4 appliance. 3 and 4, or 2 and 3 are going to be not as prevalent that you guys are going to run into in residential systems. So we'll kind of focus more on the Cat 1 and the Cat 4 categories. So if you kind of look at this chart here, you have a flue negative pressure and non-condensing for a Cat 1. Those are typically going to be your older furnaces that are 60% efficient, all up to your current 80% efficient systems. And what that means is that the inducer fan that are mounted on here to help the flue gases go outside of the heat exchanger is it creates a negative pressure within that heat exchanger. And even though it's kind of pulling those fumes through that heat exchanger at a negative pressure, it still does not positively pressurize the flue. So the flue is still a lesser pressure than the conditioned space or the attic or crawl space underneath a home. Non-condensing, as you heat fuel and you have byproducts of combustion, one of those byproducts is going to be water or water vapor. And if that water or that water vapor cools too quickly, what'll happen is it'll start to condense. So typically these flue type appliances at a Cat 1, being one, non-pressure compared to the surrounding area of that vent, and it's not going to allow it to get that cool, at least it should not. It is very close to becoming a condensing type furnace, as long as those stack temperatures are where they're supposed to be, typically between 300 and 400 degrees is what you're typically going to find on these stack temp category 1 type furnaces. Your Cat 4, well, I kind of go through all of them. So Cat 2, it's also going to be a negative pressure flue vent, but it's going to be a condensing type. Again, you're not really going to run across a lot of these, but if you do, just know that the material makeup is going to be a little bit different to be able to handle some of that condensing flue byproducts in that system. Or else, if we use the same venting as the Cat 1, then it could actually rust out and damage the equipment. Type 3, you're really not going to see out there. That's going to be, again, more of your commercial industrial type systems, but it does have a positive flue, and it is also a non-condensing type furnace. Category 4, these are going to be more prevalent. This as the industry changes with higher efficient type systems, Cat 4 is going to be installed more frequently as units are getting changed out. And a couple of reasons why. One, they are more efficient. 90+% can range anywhere from 90% all the way up to 98%. And I believe some manufacturers actually have some 99% furnaces out there. That just means when we talk about percentages on fuel, is that every dollar you spend on fuel, your rate of return off that money is going to be a little bit less. So if it's a 98% furnace, every dollar you spend, you're losing 2 cents out of that flue stack on efficiency. On the 80%ers, for every dollar spent, you're losing 20 cents on every dollar on energy efficiency. Electric, on the other hand, is always going to be 100%, typically because if I pay 100% of electricity, I'm using the 100% of that electricity to get my heating source. So that's kind of a little bit of the differences that are out there when it comes to our different categories and kind of what they mean as far as our flue vent pressures and our flue gas temperatures, and along with our venting material. Now, we kind of mentioned about the inducer draft motor. This is what creates that negative pressure in that heat exchanger on the 80% furnaces. So as it creates that negative pressure, it pulls those flue gases through that heat exchanger to get as much out of it as possible based on its design, and then exhausts it out through the flue, still at a lesser pressure than the positive pressure systems.
Hey, Eric, just one more thing. Can you go back to that slide with the four
Sure.
categories? Taking a look at category one. Now, if I'm a home inspector and I come across a category one, it's a natural draft furnace. They stopped making them. What would you recommend if I'm a home inspector and I come across a natural draft gas furnace and it looks old because it actually is indeed old? What should a home inspector say? Like, it's likely, like it could be functional, but you can't possibly be relying on it.
Oh, absolutely. Definitely my recommendation, and same when I was a contractor. If I go into a homeowner's house and I see something like this, my first recommendation is hey, this is very old equipment. You're losing a lot of energy. You're losing a lot of money every single time you're operating this piece of equipment, and I definitely recommend replacement.
Yeah.
That's the first thing that I offer to my homeowners. And that's what I would also recommend as a home inspector is I would write that up. Hey, it's an outdated furnace. You're losing energy. And my recommendation, at least as a recommendation, to change that out.
There's a high probability that there could be something wrong with the heat exchanger, a crack or rust, because it's so old and aged.
Oh, absolutely. So from a manufacturer standpoint, heat exchangers typically come with a 20-year warranty in case anything ever happens to that heat exchanger. So these furnaces are way over that 20-year time period. So one, they're not under warranty. Two, you do risk the expansion and contraction of that metal over that period of time to have multiple issues with those types of furnaces. And it's just way better to replace those, at least put the recommendation in for replacement. And if they don't have carbon monoxide testers, I would definitely not to operate it without a carbon monoxide tester, just in case that there is a cracked heat exchanger.
Now, category 4, it produces condensate. Category 1, no condensate. If I observe indications of some kind of condensate on a category 1 vent connection pipe, like the white salt deposits or something like that coming down, or just indications of watermarks, that there's something wrong with the draft or something, right?
Oh, absolutely. That usually typically will indicate that you might not have complete combustion. That'll cause it as well. That means your flue gases aren't getting hot enough, or they're cooling too fast. So one of the two, it could be a backdraft or a downdraft on that vent appliance, and it's just cooling those water molecules way too quickly, and that will leak down back into the combustion chamber. And I've got some slides that kind of show that of kind of what to look for when you're doing a home inspection. And again, my recommendation, even when I was a contractor, if I saw this kind of going on an 80% furnace, then I also recommended changing that out, because you don't know how damaged that piece of equipment actually is, and can potentially end up hurting a homeowner.
Okay, thanks.
You're welcome. So again, this was the inducer draft motor for the 80% efficient furnaces. And then, as I mentioned before, on the 90% or 90+% furnaces, you have a higher efficient inducer draft motor. It's a little bit more powerful, still creates a negative pressure within that heat exchanger. But on these systems, they have typically two separate heat exchangers. You have a main or a primary heat exchanger, and then you have a secondary heat exchanger, just to get as much energy efficiency as you can out of these systems. And here's the interesting part about these is that as the flue gases are going through this heat exchanger and air is being blown across, cooling that heat exchanger or transferring that heat to the air to supply to the home, in that secondary heat exchanger, it actually gets cool enough. That's where your condensation starts. So you'll actually have water sitting in the bottom of that secondary heat exchanger. And interesting part, just a physics note, is that as water sits there and goes from a vapor to a liquid, it takes more heat to be able to do that. So they actually pick up more heat just in that thermodynamics process of changing state from a vapor to a liquid. That's what makes these so much more efficient. And then typically your flue stack temperatures coming out of these systems, you're anywhere from 100 degrees to 140 degrees max. But on these, because it is a more powerful inducer motor, you have a positive vent stack, which means that it has to be sealed. This is called also a sealed combustion type system. So one of the things I would be looking for externally on these systems is, one, do I have condensation drain coming out of the system? Is it flowing? And two, is my vent pipe glued together or sealed properly? Those are going to be some of the things that I would be looking for on these types of systems. Some of the materials that you're going to be seeing for vent piping, BH type vent, you're going to see on these 90% plus furnaces. They could be metallic or plastic PVC type pipe. PVC is going to be your most common, more so than the BH metallic. That's going to be for your category 4. Your type B vents can be on your type 1 or type 2 systems. These just interlock. They literally just slip on, quick twist, and they lock in place. Again, you're not going to seal them fully, which again, it's a negative vent pressure, so it doesn't have to be sealed like it does on a 90% plus furnace. Single wall vent connectors, you're not really going to see these too much. You should see a little bit of C-vent connected directly to the furnace before the B-vent is applied. I've been out on many jobs where I get there and the B-vent runs all the way down to the furnace. There should be a little bit of a single wall, usually about 6 to 12 inches of single wall. And for the reason for that is that technicians need a place to be able to take measurements of that flue gas when they're doing their checks. B-vent, you never want to drill holes through. And so that's why it's always recommended by the manufacturer to have a little bit of single wall right out of the furnace, just so that the technician can take measurements and checks. A-vents are going to be your stainless steel type venting systems that can be ran through chimneys. And I've got a few other diagrams that kind of illustrate where you'll see those applications. But again, that's going to fall under more either through a chimney vent, you may see it, or on more commercial industrial type systems. Again, category 1 uses B-vent, and you can always check the IFGC to be able to ensure that it has been installed properly based on their charts and their information that they publish out there to the industry. Again, even as manufacturers, they still go by all the different codes that are out there to be able to set up their installation guides for the technician to install properly. Here's that category 2, can be V-vent, and also it can be some type of specialized material. Again, you're not going to run into this that frequently, but this is what can be used on type 2 heating equipment. Now, type 3, maybe you use stainless steel type. This is where our A-vent comes in. Or you have this type of venting material that has actual clamps that go around it and make a good seal, because again, type 3, we're looking at a similar to a positive pressure. It's not going to be as positive as your 90%ers, but it's still going to be positive enough to where we want to make sure we've got a good seal on those venting materials. Again, this is just a diagram of that A-vent coming out outside, external to a home. And it kind of gives you a little bit of a temperature range. Typically, these flue temperatures exceed 470 degrees. So they're very, very high temperature type. And anytime you have any type of venting going through or transitioning through a home, understanding the temperature is a huge key, because if I have flue temperatures going through my vent, going through that stack and exiting out of a home, then there may be materials that could potentially ignite and catch on fire if not properly transitioned outside of that home correctly. So that would be another thing that I would kind of look for. B-vent is double walled, so it definitely has its own layer of protection. So that last external part of that venting system should not get hot enough to actually cause anything to ignite, but it does get warm if you've ever touched a B-vent while it's operating. Again, our category 4 type, as you can see here, we're using PVC, and you can see where the glue marks are, where it is sealed correctly, so that it doesn't release that positive pressure flue gases into the conditioned space or within the home. Here's a category 1 setup. This looks like it's installed underneath a house. And one of the key things on category 1 also is that it uses the surrounding air for combustion. So if it's in an area where it's not getting sufficient amount of air, it can starve that combustion cycle and prevent that furnace from operating properly. So that area is known as the CAS for combustion air. That's just that surrounding air that it uses for combustion.
And
now here's a picture.
Go ahead, James. That shouldn't be resting on the concrete, right? We should be lifting that up and have it underneath it.
You are correct. And it's interesting to be able to find a lot of pictures that where systems were not installed properly. As you can see, you definitely have a coil on the top end of that furnace for the AC section, and it definitely should be suspended and secured properly, along with probably an external or emergency drain pan. Keep anything from damaging underneath that home. Now here's our old furnaces. This is what we were talking about, Ben, with the old 60 or 70% natural draft furnaces. These do not have the inducer motors like the newer category 1 furnaces have. These actually have a negative pressure inside the system, and it has an opening in the front that allows for additional air to be drawn up through the flue and mix with those combustion gases. So if you look at the grill down at the bottom, that small grill is used to pull in combustion air for the combustion system, but that top opening is used to draw in surrounding air to mix with the flue gases to help that get outside the home. Problem with these systems also is that if there is a downdraft or a barometric pressure change externally, like a storm, and this system is running, it can cause those flue gases to be pushed back into the home. And that's another reason we were kind of talking about that I would definitely recommend changing these out, not just the heat exchanger, but also these have multiple different potentials for additional hazards to a homeowner. Kind of a breakout of a Cat 1 type system. One thing I want to point out on these, your burner assembly is down at the very bottom. Okay, so that's one way to identify a Cat 1 80% furnace. You also notice that the door panel on the bottom, you can kind of see it to the far right of that burner assembly. You have a louvered panel. Anytime you have a louvered panel, that's going to fall under a Cat 1 to be able to pull in the combustion air from that CAS area. And then as it burns, it goes up the heat exchanger and then is pulled through by the inducer motor and then out the flue stack. And that's going to be a typical setup regardless of manufacturer for category 1 system. Category 2, like I said, you're not really going to see these out there, but similar setup to a category 1, but they're just going to be a little bit different. Most residential appliance manufacturers don't even manufacture a category 2 type furnace for residential systems. Your Cat 3, like I said, you may run into some of these. Typically, it's going to be focused in dealing with your oil type burner type systems. So a little bit different setup, and I have a few other breakouts that'll kind of show some of the differences on the oils, how it either goes to a complete heat exchanger, kind of like an S type, or how it goes through a barrel type like the one shown in this picture. Kind of a breakout just to give you guys an idea of how the air is going across that heat exchanger, picking up that heat, and then kind of a breakout of that burner system, the combustion system on this one's a 90%er type furnace. The way I can tell and distinguish between a 90%er, a Cat 4, and that 80%er is look where the burner location is on this system. It's up at the top. So what we do is we create our combustion at the top, and then we use that inducer draft to pull it down through the heat exchanger as air is blowing across it, and then also hitting that secondary heat exchanger before it goes up through the exhaust out of the system and to the outside of the home. Another thing about the category 4, it is a sealed combustion chamber. The reason there's 2 pipes is because, one, there's no louvers on the front of these cabinets, so it's not using air for combustion within the CAS. It's using air from outside. It actually has its own piping system for combustion air, and that inducer helps pull that air for combustion from the outside, piped into the system, uses it for combustion air, and then pulls the byproducts of combustion out through the secondary piping system or the flue vent pipe and exhaust it to the outside. All right. Any questions on that before we go on to the next section? No?
Yes. From 20 feet away for a home inspector, 20 feet away, you should be able to identify the category from 20 feet away. What would those characteristics be if you're just looking from 20 feet away? I was taking some notes, like if you got louvers in the front, that's category 1, sealed chamber category 4. Metal pipes category 1, 2 plastic pipes category 4. Burner location on the bottom category 1, burner location on the top category 4. And if you got a condensate pump, that's category 4.
Correct. Yes. If you've got condensation coming out of the furnace, that's also going to fall under that category 4 because we've got to get rid of those condensed byproducts of combustion outside the furnace, or it'll end up rusting out the bottom of that that secondary heat exchanger.
Cool.
All right. Going on to the next slide for sequence of operations. So as a home inspector, one of the things that I'm going to probably kind of look for, and I do this as a technician, is, I go to my thermostat, I set a call for heat, and I can literally listen to the sequence of operation and kind of hear that whole furnace system go through its checks and ignite. And I'll kind of run through these real quick. So I go to my thermostat, call for heat. What's going to happen is the draft motor is going to start. The reason this happens is that that furnace is now designed that if my draft motor is not running, I don't need to start, because now I'm going to create potential harmful gases that aren't going to be pulled through the heat exchanger and can potentially fill up the home. So that's one of the first safeties and first items that actually kicks on. Once that draft is proven, typically through a pressure switch, that pressure switch will close on a negative pressure. tells the board, okay, I've got draft. And then the ignition process is going to start. I'm going to send a signal to my gas valve, opening the gas valve, allowing gas to travel to the combustion chamber. And it's mixing with external air. And then my igniter is also going to light up. If it's a spark igniter, you're going to hear the ticking of that spark igniter. If it's a standing pilot, you're not really going to hear anything. It's just going to light those burner ports as soon as that gas and air mixture reaches the combustion chamber. And then it's also got a flame sensor inside of the flame that as the flame hits that sensor, it creates a milliamp or a millivolt and sends that signal back to the board and says, okay, we've got ignition and we've got a flame. Once that's proven, my heat exchanger starts to warm up and then the blower starts. So all this happens in a sequence. It's not all of a sudden. I've had customers call me and go, hey, I turned my furnace on, and then it's usually about a few minutes before my blower kicks on. And I go, yes, that is correct. It usually takes that long. And it'll go through some fail safes. And if it doesn't hit those fail safes, then ignition should happen. But if different things happen or if there's a problem in the system, it will not ignite. And so from a home inspector point of view, if you're inspecting a home and it goes through the cycle and lights and is running and we get all the way to the combustion, then everything should be fairly good. Everything else from that point forward may be needed to be checked by a technician. But if you're going through that cycle and it's going into fail mode, definitely there's a problem, and definitely a technician needs to come out there and inspect it and figure out what's going on with that piece of equipment. From an electrical standpoint, I kind of put this together just so you guys kind of have a mental note of kind of how the system works. Power from the breaker goes to a switch on the outside of a furnace. Furnace has an internal switch known as a door switch. So when that panel's not on correctly, that door switch is open. That prevents anybody from starting this system that's not qualified without that door being on. Then it sends signal to my transformer, which sends power over to my thermostat. So now I can control everything by control voltage. Board is kind of the brain. It kind of tells and sends signals to different places to tell things what to kick on at what time in that sequence of operation. First sends a signal to my inducer. Pressure switch closes, sends power back, letting the board know that we have inducer draft is working properly. Then sends a signal to my gas valve, then to my ignition. And once that heat exchanger kicks on, the last thing that kicks on is going to be my blower fan motor. And then it does this all the way until my thermostat will satisfy. Let's see here. All right. So two-stage and variable speed. I've always heard, I've even gone out to calls after home inspectors have gone to a home and said, hey, I've checked this and checked that, and these are my notes, and I just need somebody to verify it. One of the things to be different, and it's going to be more prevalent as time goes on with these higher efficient units, two-stage or variable speed, is that one, you want to test these in second stage. And typically how you do that is you run that temperature up. Let's say the house is 70 degrees and you're doing an inspection, run that thermostat up to 80. The further that gap between what it is and what you're trying to heat to, that's going to cause that system to go into second stage. Give it about 15 minutes before you run your checks. And that's basically saying that, hey, this system's running at 100% optimal capacity, which is where you want to be when you do these checks. Same with variable speed, but variable speed does take longer. It steps it up in stages. So to get it all the way to 100% capacity on a variable speed system, you're going to have to let it run for 20 to 25 minutes before you actually do your test, because it'll stage up every 5 minutes. And that's typically across the board with any manufacturer on variable speeds. All right, safeties and controls. Gas-fired appliances are very, very dangerous. Without the safety components there, and the reason they're there, one is for codes, and then two is to prevent, one, a house from catching on fire or any other type of problem that exists. It prevents it from running. Because we are using a natural fuel source for combustion, anything can possibly go wrong with these systems, and manufacturers have done a great job of putting controls into place to alleviate most of the issues that could potentially happen within these systems. So if you ever walk up to a system and you see wires everywhere and things are jumpered out, I'll be honest with you, I even as a technician, I would not even run the equipment. You don't know who's jumped what safeties, and it could be a potential hazard for you even just operating that piece of equipment. First safety is going to be that pressure switch. That's there again just to make sure that inducer fan motor kicks on. And that's what it's going to kind of control. Your other safeties that you have these numerous temperature switches that are preset for a certain temperature, and they're placed all throughout the furnace cabinet around where the combustion chamber is. And this is to sense the temperature. If the temperature gets too hot above the design specs, these are designed to trip out. That means that there's a problem with the combustion. Maybe I don't have enough airflow across that heat exchanger. My heat exchanger is getting too hot, and I don't want to damage that heat exchanger. So I want these safeties in place and operating properly to make sure that I'm not doing more damage to that equipment or potentially damaging somebody's home or hurting somebody. Control boards, they're the brain of the whole operation. Years and years ago, if you look at the really old type furnaces, you didn't have control boards. They usually had like some kind of relay or some type of control that kind of jumped from one relay to another. Boards kind of overtaken that kind of technology. So these relay boards, they do everything internal. Your gas valve, again, that's going to have supply fuel system source going to the gas valve at a certain pressure, and then it's going to regulate that pressure down to a working pressure. If I go and I start a furnace and I've got a flame that's just roaring and is very, very strong, that's going to be an indication to me that I might have my gas valve might not be producing the correct amount of pressure of gas to my combustion chamber. And that could be a huge, huge problem. So just something to kind of think about if you do see a flame or hear a flame that's just roaring uncontrollably. Some of the components, heat exchangers. These are just different types of heat exchangers you might come across. They're very hard to see. They're all hidden within the cabinet typically. But these are what they look like that are going to be out there. The one on the top right, that's your 90+% furnace heat exchanger. You have your main loops, and then it goes down into a secondary heat exchanger to get as much efficiency out of them as possible. The one on the bottom left or bottom center is actually going to be your 80% plus furnace type heat exchangers for the most part. And same with the ones on the left. It just depends on the manufacturer and which type of heat exchangers that they're actually using. Here's a problem we run into with heat exchangers. They do fail. They can fail. And if you ever start up a furnace and you're looking at the flame as it's going and the flame is dancing, it's kind of moving around in that port area, and it's not steady, that's a great indication that there may be a cracked heat exchanger. In that case, I would shut the equipment off. If you do have a carbon monoxide tester, you can check at the vents or registers and see if you are sensing any carbon monoxide. And if so, shut it off completely, condemn the unit, and definitely tell the homeowner they cannot operate that piece of equipment until it is repaired or changed out. So venting, we already talked about venting types as far as appliances, but now let's see where they need to transfer out of any type of home. As a venting system, we want to make sure, one, we're not venting flue gases into the conditioned space. We want to remove all flue gases to the outside atmosphere. Prevention, we want to prevent any damage from condensation if it's not a 90+% furnace. So we don't want that to condense before it exits out the home. And we, of course, want to take care of the building structure from any kind of fire hazards. That's that transition I was talking about earlier. Again, here's some pictures of some proper transitions for those flue gases kind of coming out of the home, kind of keeping it away from that combustible material. Also here, it kind of identifies what our products of combustion are. We have carbon dioxide, nitrogen, water vapor, and carbon monoxide. And they've all got to be removed outside the home. These things do happen. Furnace isn't operating properly. The flues get too hot or out of spec. Maybe a technician was working on it, couldn't figure out the problem, but knew safety was the problem, so he jumpered it out. And next thing you know, the house burns down because something caught on fire or it wasn't installed properly. And ironically, as much as I've been in this field, you do see a lot of companies and a lot of technicians that really don't know how to install some of this equipment. And I say that because there's many different types of companies that'll go get their license, get started. I can tell you, for an example, here in Phoenix, Arizona, 1,100 licensed HVAC contractors. And with that many out there, people are just getting the license and they're not really following the practices. And so you guys actually have the opportunity to identify something when it was installed incorrectly, either per the manufacturer's specs or by any of the local or national codes.
When you
kind of talked about, go ahead.
When you install an HVAC system, are you required to keep the manufacturing installation instructions on the unit itself, like in a bag or a holder?
Yes. So typically, two things I usually do. One, the homeowner is the one who actually purchased the equipment. So typically, I take all the literature for that piece of equipment, and I'll give it to the homeowner. And I know a lot of contractors, they'll put it right in the cabinet just so if technicians need to come out there. And you can do it either way. There's nothing saying that it has to be within the chamber so a technician has it right away. I prefer to give it to the homeowner and just tell the homeowner, hey, look, keep this in a safe place and hang on to it. Don't throw this away. The good thing about the newer pieces of equipment, right inside the unit on the data plate for the furnace, a lot of manufacturers are putting these QR codes. So as a technician, even if the literature is not there, I can actually scan it and it'll bring up all the literature on that piece of equipment that I'm actually looking at. And I can kind of glance through it to kind of see different technical stuff, and then also if it was installed correctly per the manufacturer's specs.
Are you saying that's on the front panel or on the motherboard, that QR code?
So as soon as you open the panel where the combustion chamber is, there's usually a sticker, a data plate sticker, right on the either right or left side of the cabinet.
Cool.
So those are, and it's a great tool, and I'm kind of glad that they're doing that. Makes it a lot easier, especially when literature has been lost over the years. So, but no, it's not a requirement to leave it in the equipment. Some of the things you want to look for: damage and prevention from condensation. If I've got an 80% furnace and I open it up and it looks like this, I've got a condensation issue with that flue gases. So immediately, I'm probably going to write that up and recommend to whoever my customer is that, hey, you need to get a service technician over here to further diagnose what's going on with this system. typically, if I come out and I see that as a technician, my recommendation is automatically going to be replace the system. This just kind of indicates a couple of problems associated with venting systems. This one's showing a 90%er. This one's coming out near the bottom of a home. So as you can see, a 2-pipe system. One's going to be your air intake. That's going to be your top one. And then the one on the right is aiming downward. That's going to be your exhaust flue gases. Now, I can tell you this based on just looking at this picture, if my flue gases are showing going down and my intake is higher, I'm probably going to be pulling in some of those exhaust fumes for combustion air, and that's not going to be good either. And we'll kind of look at this a little bit more in some other slides. But definitely want to make sure those are clear, not plugged, unrestricted from anything on the outside. And I've got a lot of pictures that'll depict some of the wrong ways of venting these type of systems as we go down through these slides. Now, venting design, a lot of times, especially as either a homeowner, or let's say even if you guys are inspecting things, if you go on and you're like, okay, I'm going to go turn every single thing on, make sure they work all at the same time, you could potentially be starving that furnace of air. It uses, especially an 80%er or less, is going to use air for combustion that's around it within that CAS system. And so if I've got vent fans going, I've got dryers going, I've got other appliances that are exhausting air out of my home, I'm going to create a negative pressure in that house. Once I do that, I'm going to starve combustion air from that furnace. So when I go and take my temperature measurements or look at the operation of this furnace, I may have created additional problems just by kicking everything on. So I would always say, if you run across a situation like this, run the furnace first, get it up to temperature, and do your checks on it before you go and turn on other appliances, because you could be seeing a problem that's really not a problem. It's just because everything else is running and exhausting stuff out of that home and creating a negative pressure. I've gone to jobs where the Saturday morning, they're cooking breakfast, got the kitchen vent fan on. They're also doing a load of laundry, and they've been having furnace problems. Well, I get there, they're not doing that any longer, and there's no problem that I'm able to see. It's only happening when all these things are running. Another thing to kind of look at when you guys see the vent piping is it should always be to somewhat pitched in an upward direction for the exhaust vents. And this particular is on the 80% plus, and here's why. It's natural draft, so we're at a negative pressure in that heat exchanger along with the negative pressure in that stack, that we want that to naturally draft upward. If there's any bends or any pitches downward, now we've created an area where it can start to cool off, and then we're going to get condensing within that flue pipe, which water and metal do not mix. So you will eventually rust it out, and now you're going to create additional issues with that. So always make sure there's at least some type of pitch in an upward manner when inspecting vent pipes and how they're secured. Again, just some additional things to kind of look at when you're looking at the 95% furnaces and you're looking at the vent pipes. Make sure that they are strapped. They should be strapped with some type of metal or plastic or large wire ties. And they should be strapped in a manner that they're not sagging. If you ever see PVC pipe over a long period of run, they'll start to sag. That should not be like that. It should be secured well enough so that you don't get any kind of sag on that venting. A couple more slides and then we'll go on a quick short break. Single pipe systems, again, this kind of illustrates that negative pressure in that home with a single pipe vent only and exhausting out of that home. also known as a non-direct vent. They're less efficient than a two-pipe system. They freeze up less and they also cost less to install, but they're harder on the heat exchanger and the combustion air from wherever the furnace is located. Again, this depicts that air issue for combustion air, getting proper combustion to that furnace. And then if we look at the different design on the more higher efficient furnaces, we don't have that problem with the two-pipe system on our 90+ percenter, because we're pulling air from the outside area, not in the CAS around the furnace. And then we're sending it through a sealed combustion chamber and then exhausting it right back out of the home. So this doesn't play a factor on it. So not only is it more efficient, you actually deal with less problems in operating. And it's known as a direct vent system. It's also very, very quiet compared to an 80% furnace because of that sealed combustion chamber. And we talked about that improved efficiencies. We'll go ahead and take a break, Ben. We're about at right at that 1 hour mark. Sure. And then we'll come back and we'll kind of show some pictures for the different venting transitions coming out of a home.
Sure, that sounds good. How about at the top of the hour? We'll start again.
That sounds perfect.
Okay, so that's about 4 minutes, maybe a little bit less. So Eric, you can take a break. Folks, everybody can take a break. What I'm going to do is I'm going to stay on live, and I want to take questions from anyone attending the live webinar that's not related to the topic, but is about InterNACHI. So I'm here to answer your questions. If you have a question about InterNACHI membership, business, marketing, websites, or anything like that, we can talk and I'll answer your questions if you like while we're on this little break. So everybody take a few minutes, get a break, hit the restroom, reheat your coffee, and Eric will be back and we'll start again in about 3 or 4 minutes or so. But if you're interested, I'm going to share my screen. Let's move everything out of the way. And what I want to share with you is if you're a member or a non-member of InterNACHI, let's see, I want to make sure I got my controls so I can come back. Go to nachi.org/everything, nachi.org/everything, nachi.org/, that's that little slash by the question mark on your keyboard, everything. And this is a 15-step checklist on how to become successful as a home inspector, right? Some advice. And there's 15 steps. So if you are a member of InterNACHI, if you're not a member of InterNACHI, I still recommend going through it. Step 1 is join InterNACHI as an organization. If you're not a member, feel free to ask me how to become a member, or you can go step 1. Step 2 is to get trained and certified. Let's just jump there right now. So if you are interested in becoming a home inspector, we have the Home Inspector Certification Program. It's free and online for InterNACHI members. We also have 60 different types of inspector certifications, and they're all free and online. And because we're a home inspector college, accredited by a national accrediting agency, recognized by the U.S. Department of Education, you're a real college student. And it's a tuition-free school with internachi.edu. And you can take any of our certification courses. So if you wanted to be a 4-point inspector, that's important down in Florida. If you want to become a drone pilot, we have a drone pilot training course. If you wanted to know more about lawn irrigation systems, you can become a lawn irrigation system inspector certified through InterNACHI, and that's one of the steps. You want to diversify your services by being trained and certified in various types of inspection services. So you're not just a home inspector, but if you're doing a home inspection and you happen to feel that high humidity in the basement or crawl space, you may see some water intrusion problems, maybe some condensation on the windows on the inside during certain climates conditions. You may want to become a moisture intrusion inspector, certified mold inspector, and then turn to your client during a home inspection and say, while I'm here, why don't I take a look at this potential problem for you? Joseph asks, how am I recording attendance? Do I take attendance for webinars? So The attendance will be taken through our Zoom system. We can see who attends, how long you've been attending, and then you can upload evidence or proof that you've attended the entire class into your InterNACHI dashboard and get credit for it. If there isn't state licensing credits for webinars like this, right? They're live, they're kind of informal, we can go off topic, and states don't really like that. They like more formal classes. And that's what we do online. Through our home inspector college, you can take a course that's state approved for state CE. That's what I would do. If you're an InterNACHI member, it's free and online, and it's learn at your own pace. So Roy, that's the question. Is InterNACHI credited towards CE for state license? Yes. So we're recognized by all the states. If you have if you're a home inspector in a regulated state, InterNACHI is approved by that state to provide free CE, but they don't like to issue or award credit. The state licensing boards don't like to issue or award credits for webinars like this that are informal, and you can't get CE by watching a video if you're happen to be watching a video right now. William asks about connecting CE PVC pipes. We can ask Eric about that when he comes back on in a minute or two. Let's see, a couple of questions about material defects. Paul asked, with only 3 categories to describe a problem on Spectora software, how do you differentiate between material defect, major, minor issues, health, safety issues, and maintenance comments? That's a fantastic question, and we answer that in the report writing defect course. So we have our course about how to observe and identify defects, and then how do you report upon those observations accurately. And material defect is that special kind of defect that Eric kind of touched on that is going to hurt somebody. It's going to have an adverse impact on the value of the home, or put somebody in a dangerous situation where someone's going to get hurt. And that's called a material defect. Doesn't mean like it's made out of concrete or cotton, not that kind of material, but a material defect meaning major, where there's an imminent danger to someone. So we help you identify those types of defects. And those different types of defects, Paul, that you mentioned, they're also in our glossary. So you can look up those definitions. What is a material defect? What is a safety? What is a major or minor defect? And if you need any additional help, feel free to email me, ben@internachi.org. And I can see our instructor has come back. Awesome. I think you can just grab the screen again. Can you screen share?
Okay. Let me get to, there we go.
All right.
Is that the right screen that you're seeing?
Let's see, it's coming up.
Okay.
I see black. Let's give that another try.
All
So
right.
let's put it on my
A
side.
little different. There we go. Now we've got it. Does that come up now?
No, I see just black on my side.
Okay, let's see here. What is that? Let me stop sharing for a second and let's try this one. Is that still not coming up? Interesting. Let's see.
If you can, folks, if you can chat, whether you can see Eric's screen or not. I see black on my side. No. Paul says no. So if you maybe close out your PowerPoint presentation, still see black on my side. Then bring up
close that real quick and I'll reopen it. Let me make sure I'm on the slide.
And when you share, you gotta find that opened PowerPoint presentation screen.
Here we go. Let's try this.
And if that doesn't work, then there's other things. You can log out completely out of Zoom and then log back in.
All right, this should work. Into the right slide and okay, let me go to share screen.
So while Eric's doing that, Matthew, you're talking about Ontario, Canada, unregulated except for legal stuff. We're moving towards regulation, wondering if InterNACHI certification might apply. Yep. So we are working with our good folks on Canada to make sure that we can serve our members in Ontario. And Eric, it's still a black screen there, I believe. Folks, can you see Eric's screen? Paul asks, how long do you have to, same, yep, nope. How long do you have after completing courses to take the state test? Is there a time limit before having to retake classes? How long do you have after completing courses to take the state test? So Paul, where are you from? Why don't you chat where you're from so I can help you in that regards? Because if there's a state exam, most state exams are available to you at any time. I can't think of any state exam where you have to do education in order to qualify. Like for Florida, for example, you can take the Florida Home Inspector exam at any time. I don't know, Eric. I don't know what's going on.
Let's try this. One more try on this.
Maybe try a screen and then slide, or if you're using two monitors. Illinois, Paul says Illinois. So yeah, you can, you know what you can do? There's a InterNACHI chapter, member chapter in Illinois, and they're really good at helping folks get licensed. We have some chapter presidents there, some folks who teach live classes, certified master inspectors. So where you want to go, Paul, is nachi.org, nachi.org/Illinois, and then scroll down that page and find resources that you need about taking that state exam. Roy says, MS, Mississippi exams require 60 hours of education, but not clear on timeline. Yep.
Is that coming up now?
No, it isn't, Eric. Folks, do you see Eric's? Yeah, so Ibrahim says you might be showing your second monitor by mistake or something like that.
Oh, okay. Yeah, let me try. Let's try changing that one.
So go, Paul and Roy, and everybody who's wondering about state requirements. You can always go to a nachi.org page, nachi.org/ and then just type in your state. If you're in Washington, D.C., no space. So just type in New Jersey, New York, no space. So type in your state after nachi.org and a / and get more state-specific information there. And we also have a contact page. So go to anynachi.org contact page. anynachi.org page, and then at the top, scroll down to our contact and contact your education team. The education team works for you, and they'll be able to help you specifically. Eric, it's still black. What do you want to do? You want to pop out? Do you know how to get back in? Can you find that link as a presenter?
Let's see. Yeah, I can. I'll pop out and then I'll just reconnect to it.
Yeah, maybe that'll work. I don't know.
Let's try that.
Okay. We can just keep talking over here. Mohammed, just wondering if these slides will be available on the InterNACHI site for review. We'll ask Eric that question for sure. Maybe you can share them and then we'll put them up. And then you can email me later. Why don't you email me next week sometime, Mohammed, ben@internachi.org, ben@internachi.org. And then, so let's see here. While Eric is getting that together, let's see what we got here. I want to show you one more thing. Oh, there he is. There you go. There's Eric.
There we go. Now let's try this.
And folks, we did practice this a couple times.
Yes.
All right, you got it.
Okay, is that the main screen or is that the one with the slides on the side?
That's with the thumbnails on the side, and you're at your first slide. So you have to do a presentation and scroll all the way down wherever you were. I think we were doing venting and CAS and pressurizing and depressurizing the home. Those slides there.
Perfect. Here we go.
Thanks everyone for your patience. We do our best with this technology. There you go. I remember that one.
All right, so we're on there now.
Appreciate it.
Okay, so some of the common vent pipe that you're going to be looking at when you're dealing with these 90+% furnaces is the transition to the outside of the home. Very, very important that these two are not in direct contact with each other as far as the combustion air intake and the exhaust outlet. So as you can see in this first diagram on the left, it talks about or it shows a air intake pointing downward and then the exhaust vent going higher, because those gases are going to be higher in temperature and also in pressure. So we want that vent to be higher than our combustion air intake area. As long as we keep that in mind, that the vent's going to always be higher than the exhaust, that's going to prove, or the air intake, then we want to not be able to pull those back in to there. Let's see, next screen. Mine's showing something weird. There we go. All right. And then, of course, the one on the bottom is showing there is opportunities where it can be a roof transition for the exhaust and then possibly run aside for the air inlet so that it kind of keeps the two separate, or vice versa, two parallel, running out two different areas of the home. This is just to give you guys some examples of it. When you're looking at concentric termination kits, you'll see a single pipe coming out and it'll just look like a single pipe unless you know what you're kind of looking at. But the concentric type is a pipe within a pipe. So the outer pipe is your fresh air intake, and then the center pipe that runs straight through is the exhaust. So what'll happen is air will come behind this kind of raised area and be pulled into that outside pipe and go through that wall, and then it's got an area where it branches off and goes to the air intake, and then the exhaust is in the center of that piping. So you may come across some of this and go, wait a minute, why do I only have one pipe? Well, that's a concentric type termination to allow, instead of having two holes go through, we're using just one single type of pipe, and then we're still doing the same exact thing. And it keeps the flue gases and the air intake separate. Some of the things to kind of pay attention to, termination considerations. The exhaust fumes are near 100% relative humidity. That's why they condense. And they'll also condense on nearby objects. They may drop condensate low termination. That is slightly acidic as far as that gas or that condensation, just because it does have a little bit of the other chemical makeup for byproducts. So it can be a little bit acidic. That part I kind of point out because certain local codes might dictate that if you have a condensing furnace, that they may not be able to, in that area, drain directly into a drain pipe, into the sewer or septic systems. So that's just something to kind of pay attention to when it comes to 90% plus condensing furnaces. And we also want to prevent against freezing, because if it's really cold outside and I've got flue gases at 140 degrees and that water vapor starts to freeze up, it can actually clog that exhaust vent pipe. And I've got a picture on that a little bit here in a few. These are just different termination kits that you may come across. They work exactly like the concentric in a way. They're just a different setup. If you come across where you've got a furnace, a 90%er, and they're running that exhaust fumes down through a sublevel and then terminating out, let's say, a crawl space, there's some specifics that you want to kind of pay attention to when you're doing your home inspections. Here's kind of this little drain pipe or T that kind of comes down. And if you notice, it doesn't go in the same line facing where those flue gases go through. It actually, where the condensation will drain backwards into that. So as you can see in these pictures, how not to install them, because these will not work properly if they're installed in that manner and can potentially cause backup of flue gases and risk of carbon monoxide. Some areas may have to have heaters because it does get so cold, and we want to prevent that from freezing. So if you live in a high or a very, very cold temperature climate area for most of the year, you may come across where you see these cables. Or if you're doing your inspection in the middle of winter and you see that it's completely frozen because that condensation is frozen inside that vent pipe, then you might want to put a recommendation that they get a heating system just for that pipe so that it doesn't freeze. You'll also see if it's not piped correctly, or as it's coming down, you'll have it draining right off the end of that pipe. And these are all kind of bad things. These are things that should tell you that, hey, I need a heater on that pipe. So again, here's our terminations of two different pipes. This is going to be the most common because it's a lot easier for a lot of technicians. They're just going to come straight out, have a straight pipe, and then your air intake. Here's the problem with that one. Problem is that the vent flue pipe is lower than my air intake, which means all it's going to do is suck right back in there for combustion air, and that's not what we want on these systems. Two pipes just coming out of the home, that's not good either. You need it to be set up in a way that we have our air intake separated from our flue gases, especially in a tight area like that where you might get gusts of winds that might push that flue gas right back into the air intake for that system. You may come across something like this, or have already seen this, where people decide, hey, I'm going to build a porch, and they just build it right through or around any of the type of heating or air conditioning type of equipment. Again, this would be a huge write-up and say, you can't run this furnace until this is fixed correctly by a professional. Another thing too, we know how important condensate drain traps are on air conditioning equipment, but they're also just as important on condensing furnaces. Good thing is most manufacturers provide a specific condensate drain trap for flue gas condensation outside of furnaces. So as that pipe comes out of the furnace, it should drop right into this type of condensate drain trap before it goes out. If it's just a homemade, like a air conditioning type P-trap, that's definitely not going to work. And that would be something I would definitely point out to the homeowner for the furnace section of it. All right, this slide is application of various furnaces. This is just to kind of point out the different furnaces, burners that you're going to actually run into. As you can see here, you got a pretty nice steady flame in this video. and it's blue, and it's doing what it's supposed to do. This is kind of what you're going to be looking for when it comes to a flame inside of these furnaces. You want complete combustion. You want rapid carryover flame. That means when it ignites, it's going to ignite each burner pretty quick and evenly. Should be a fairly quiet operation. It should be like a very low rumble, just nice, quiet. Like I said, if it's too high, then you've got some kind of combustion problems going on with that system, and it definitely needs to be addressed. Should be immediate. I've seen some furnaces out there, you go to start, and gas for some reason is building up in the combustion chamber, and when it goes to start, it makes a small explosion. Again, that would be something that I would note as a problem, and they would need somebody to come out and check and see what's going on with that flame. And you want definitely uniform heating and stable flame performance. The classifications we classify as far as burner classifications, you have your natural drafts, your fan assist, and your forced draft. So a natural draft is like we were talking about with the really old 60-70% type furnaces, where it just allows air in the CAS area to mix with the exhaust fumes to go outside the home. Fan assisted, that's your regular intermediate type draft inducer fans. And then your forced draft is what you're going to see on your 90%. It's going to create that positive pressure on the forced draft burners. And then your burners, atmospheric burners, pre-mixers, or nozzle mixing. This is just to show you that there's just different types of burner classifications, different burner ports. They've changed over the years. Most manufacturers today use the in-shot burner, and that's kind of what we saw in this diagram here. These are the in-shot style burners on newer equipment. Old styles you're going to run into may look where it's got multiple different ports. And then just has it's just a different setup all the way around. This is what I was kind of talking about with the burner classifications when we were talking about the oil fired. Here you have an open combustion chamber where it's just a solid, looks like a barrel or a tank, and then it just blows flames in it. Your air, so your return air blows across that heat exchanger, picks up that heat, and then that heat just goes straight out the flue. This is pretty inefficient because you don't have the multiple loops to get as much out of that flue gas and that flame as possible. Whereas here you see the different loop type systems before it actually goes out. Again, this would be a forced draft, and this one's forced actually by the fan motor that's built onto that burner for that gun type burner assembly. So we have different types of burners that you'll see out there. Again, these are mostly the old style that you'll see. You've got a slotted type where each slot almost looks like a gas grill. You'll still see those furnaces out there. You have these ribbon types. That's where you have an independent flame that just kind of burns all the way across. Looks like small candles. This is like an initial type of an in-shot where it just kind of almost looks like a turbo torch type tip that blows the flame right into the combustion chamber. And then your most modern in-shot burner types is what you're typically going to see nowadays on burners. Along with burners, ignition systems are going to be different depending on what we're looking at and what kind of system it is and how old that system is. You have these different types, like especially standing pilots. Standing pilot system just has an additional line off the gas valve that supplies gas to a port that typically has a flame burning on it at all times. It's just a small little flame, and when they get that call for heat, it uses that flame to ignite those burner ports when there's a call. Again, you won't see these except for on older equipment or water heater type systems. You also have the manual ignition, where it will light a pilot, but it's not a standing pilot. So usually by a direct spark ignition with some type of hood or head on it to kind of protect that flame from blowing out. Here's an example of one, intermittent or interrupted ignition system. So the spark hits and sparks to this casing that's right above it. You got a little bit of gas coming out of this pilot port. It lights that pilot lights, that lights the burners, and that's how those type of systems will work. And those are pretty common. Those are still out there that you'll see on older equipment. Then you have also your direct spark, kind of the hose and the whole contraption of what it looks like. And these are the ones that usually make the loudest noise when they go to ignite, because it's that high spark. These usually run about anywhere from 7,000 to 14,000 volts. So they're very, very powerful. You really don't want to be touching the cabinet when these systems are lighting off, just in case there is an internal problem, because if it does short out, that voltage will light up that cabinet. And if you're touching it, then it's going to go through you. Other types of direct spark ignitions, these don't make as much noise. These just kind of make these small little arcs between these two connectors, and that lights that gas air mixture as it goes through the combustion chamber for ignition. These are the more modern. This is what you're going to see in the newer type of equipment, hot surface igniters. The one on the top, that was the first style of hot surface igniters. They glow similar to like a stove. It's a kind of porous material, very, very delicate. They can break very easily. Handprints on technicians. I tell technicians all the time, don't ever touch that material on the ignition hot surface igniter, because the oil from the fingers will actually cause it not to get hot in the areas where that fingerprint is. They've been having problems with these breaking quite frequently. So the manufacturers have come out with this newer style, nitride igniter, hot surface igniter. And these are almost indestructible. We've actually ran tests where we've driven these into 2x4s, supplied power to it, and caught the board on fire multiple times using the same one. So they are very, very much more efficient, and these are on a lot of the newer, I would say over the last 5 years, type of ignitions that you'll see out there. Again, this just kind of goes we talked about the sequence of operation. Once we have our flame, we have to have something that can sense that flame and send a signal back to the board. It just basically proves that there is a flame. It tells the system, hey, I've ignited the gas and everything is operating properly, and I do have a flame, and it will send that signal back to that board. Oil type burners will usually use a optical flame sensor. What it does is it kind of looks at the flame in a different way, using like an infrared, and it just basically proves that there is light and that there is a flame, and sends that signal back to the board. Typically you'll see these on any kind of oil fired burners. Any questions on gas furnaces or any type of furnace appliance?
We do have a couple questions. There was one by William. Does the condensate actually damage a septic system?
So it doesn't really damage it. It's just going to be slightly acidic compared to normal condensation from an air conditioning coil. And some codes, depending on where you live in the country, may have some regulations on it. I can tell you from the manufacturer's standpoint, they're going to tell all their technicians, you know, hey, just run it, but also just be cognitive of the septic system codes of wherever they're installing that piece of equipment. But as far as hurting it, no, it's not going to do any kind of damage to it.
Matthew asks, do concentric pipes create more condensation due to cooler air shrouding the exhaust pipe?
It does cool it down a little bit more. So let's say it's 0 degrees outside, we're up north, we're running this furnace. You are going to get a little bit of that heat transfer through that PVC piping, and it is going to cool down those flue gases quite considerably, but it shouldn't cool it down to where it's going to freeze within the pipe. It's usually going to be where the flue gases actually come out when it hits that super cold air. That's where you're going to get the most of your additional condensation and frost and ice buildup.
William asks, can rubber couplings be used to connect CPVC pipes? I guess on a Cat 4, like a rubber ferncoes, instead of gluing the pipe connections.
It should be able to, because your temperatures aren't that high. As long as it's an approved sealant to be able to seal those. And again, that would probably have to come back from the manufacturer code or any of the gas categories, what they recommend for using to seal those. I wouldn't see a problem with it just because it's not that high of a temperature.
That's all the questions we got.
All right, perfect. All right, our last section that we're going to be talking about today is going to be the air conditioning systems. All right, couple types and configurations that you'll run into out there. We have the package units, which is down here on the bottom. That's where everything is built into one system, and then it's just ducted in externally into a home. You have your split systems, which are typically your most common that you're going to run into, and it could be a split system between an outdoor unit and an indoor air handler, or an outdoor unit with a furnace with a indoor coil to make up the other side of that air conditioning system. All right, so let's kind of get into air conditioners. How does an air conditioner work? There's 6 main components that you have to have for an AC system to work properly. And I'll kind of go through these fairly quickly. Your compressor, a condenser, a metering device, evaporator, condenser fan, and indoor blower. All we're doing in AC world is transferring heat. That's the whole purpose for everything that we do when it comes to refrigeration appliances. We just want to move heat. Compressor is basically going to be your heart of your system. It's the one that takes a low pressure, low temperature gas vapor, refrigerant vapor, and it's going to compress that vapor to a high pressure, high temperature vapor. And kind of gives here as a diagram as that refrigerant comes into it, and then as it discharges from the compressor. Once there, it's going to go through the condenser coils as a high temperature, high pressure refrigerant vapor. And as it goes through, we have a fan motor directly on top of that condenser that's going to draw air through the sides and then up out the top of the condenser. And as it does that, it cools that refrigerant down. And as it cools, it will condense the refrigerant into a liquid. Once we have it condensed down to a liquid, we want to continue it through the piping system, and we want to go to our metering device. Now, a metering device, we want that refrigerant to be as much liquid as possible before it gets to the metering device. We kind of talked about the fan already. So as liquid comes in on this metering device, only thing it does is it has a small port that allows that refrigerant to go through. And once it comes through the other side, it goes from a small diameter area to a larger diameter area. And that increase in area causes the pressure to drop and the temperature to drop pretty much instantaneously. It's just the properties of the refrigeration and how it circulates through a system. So now we've got low pressure, low temperature liquid going to our next component, which is our evaporator coil. As this liquid refrigerant goes through this coil, air from your blower motor is drawn across that coil, causing the liquid to actually pick up heat from the house, and it boils off that refrigerant, a liquid refrigerant, into a vapor refrigerant. Once it leaves there, it leaves out as a low pressure, low temperature vapor. And again, there's your blower motor that blows across that coil. That's why if you ever see a frozen coil, typically it's because of low or no airflow. If I lose airflow across that coil, it's going to eventually freeze up that coil. And then it's just going to cycle back down to my compressor, and it's almost like a lazy river. It just cycles through that refrigerant through that entire process. Some of the things you want to kind of look for in these refrigerant systems is anywhere there's a joint where it's been soldered together, making sure that you don't see any oil. Signs of oil typically means that there's a leak. Plus, when you do your temperature check, AC system, it's not going to really be blowing that well. You're not going to get that cold air or a temperature difference if the refrigerant has leaked out. Also, as you notice in this picture, you have a filter dryer. Most manufacturers today actually install a filter dryer within the condenser system itself. If you ever come to one of those systems and you look inside with the fan not running and you see a filter, and then you look on the outside of the line set and there's another filter, more filters is not a good thing. That would be something that I would definitely annotate, is that there's 2 filters on that system when there should only be 1. The suction line, the cold line or the bigger line, does get cold, and so it has to be insulated for many different purposes. One, you want to make sure that you keep that refrigerant as cold as possible and it's not picking up too much heat from the outside area or the run through the home.
And that filter, that's one of those components that you can like cheat and take a look at. It'll have an arrow on it, and if it has 2 arrows going in an opposite direction, it's a heat pump. Is that right?
Yes, that is absolutely correct. I've seen all kinds of different things out there that's just wrong. If it's a heat pump system, you want to definitely make sure that it is the one with the 2 arrows. If it is a single system, just a straight cool AC, it needs to be a filter with the 1 directional arrow only. It does not need to be a 2 by-way arrow. And there's a lot of contractors that'll put the 2 flow in, whether it's a heat pump or an AC system, and it should just be 1 direction for straight AC, 2 direction for heat pump. And I've seen it on heat pump where they put the 1 directionals in. That creates a restriction and causes all kinds of problems as well.
Okay.
The suction line filter, that's a bigger filter. And what these are designed for, they're not designed to be in the system all the time. What happens is let's say a compressor burns out and you have acid that builds up in the system due to that burnout. You put these in to get all that acid out of there after you change out that compressor. Once you've ran it for so much time, you go and you pull this out of the system, you put another filter in there, and then you keep doing that until usually about 2 or 3 times. So if you come to a home and you see a filter on the big line set, that needs to be taken out of the system. They're not designed to be in there long term. They're just to remove acid from a burnout of the system. So just some of the notes you can kind of look for when you guys are doing home inspections.
Just one question.
Yes.
Paul asks, is the metering device the same as that thermo expansion valve?
It is. It is. The thermal expansion valve, it operates, it modulates based on the temperature of the refrigerant coming out of the evaporator coil. It'll either say, hey, I'm too warm and I need to open up and let more liquid in, or it'll say, hey, I'm too cold, I need to shut down a little bit, and it just meters that refrigerant in. Some can be fixed metering devices, some can be TXVs. So it just really depends on the system setup and what that manufacturer installed on that equipment.
Okay, thanks.
Okay. And again, a package unit, all this same refrigerant cycle and components are all in one cabinet. So here, now that we kind of looked at the sequence of how everything flows together, on the left side, you have your either air handler with your coil or your furnace with your coil. Return air comes in through that component and blows across that evaporator coil. heat transfers, that hot heat goes into that liquid refrigerant, boiling it off. At the same time, it cools down that air, and that's how we get cool air supplied to the home. Outdoor does the exact opposite. External air is pulled across the coil, the condenser coil, by the fan blades and pulled up through as it also gives up its heat to the refrigerant, condensing it, or cools the refrigerant down. Electric heat strips. So if you've got a heat pump system or even a straight cool system with an air handler, you may see some where they'll have external heat strips in there as auxiliary heat. Now these play a huge factor for heat pump systems specifically, because a heat pump goes into what they call a defrost mode. And so we've kind of seen a straight cool AC cycle of refrigeration. We see that the outdoor coil gets hot, the indoor coil gets cold. On a heat pump, what we're going to do is we're going to add a valve, which we'll see here in a second, and it reverses the flow of refrigerant. It sends that hot refrigerant to the indoor coil, and then it sends the cooler refrigerant to the outdoor coil. So if it's 0 degrees outside and I'm sending already cold refrigerant to that outdoor coil, it's going to get a chance to freeze up. And there's safeties and defrost control boards that will make it go into normal AC mode to heat up that frost so it doesn't frost and stays efficient. But when it does that, you in essence turn that heat pump back into a straight AC, and now you're blowing cold air into that home. So one of the things I always look for with a heat pump system is to make sure that they did install heat strips, because if they didn't, when it goes into that defrost mode, you're just blowing cold air into that homeowner's house. Again, here's that reversing valve. Typically, to find out if it's a heat pump, a quick, easy look down below the fan blades on the condenser. You should see this device. And what that is, that tells me right away this is a heat pump system. So that's going to be one of your easiest ways to tell. The other is to look up the model number and see, and typically it'll tell you online if it's a straight cool or a heat pump. But this is the easiest visual way to see the difference. Again, here's just the same refrigerant cycle. The one on the left is what we were seeing in straight AC. Your indoor coil is the evaporator, your outdoor coil is the condenser. When I go over on the right side to heat mode, that reversing valve slides over and it just redirects the direction of that refrigerant. So now my hot refrigerant is going to my indoor coil and my cold refrigerant is going to the outdoor coil. It's doing the exact same thing with the airflow. We're still transferring heat across both coils to either make it absorb heat or remove heat from that refrigerant. Here's a picture of a heat pump that had been operating and did not go into defrost mode and ends up frosting or freezing over. If you come across something like this, definitely write that up, annotate it, that, hey, the heat pump system is not going into defrost mode, because that's something that definitely needs to be checked out by a technician. Now we're going to look at, since we saw how it operates from a mechanical standpoint, from the user standpoint, how an air conditioner works. Again, we have power going to the indoor unit. That's to power our indoor blower fan. The outdoor disconnect, going to run through a set of contacts that's going to power my compressor and my outdoor condenser fan. And the transformer is always going to be on the inside unit. Unless it's a package unit, then it'll be in the package unit control section. But that transformer sends your 24 volts to your thermostat. Once you put it in whichever mode that you're using, in this instance, it's cool mode, it's going to send a signal to my contactor, pulling in that contactor, supplying power to both outdoor fan and compressor simultaneously. At that same time, it's going to send a signal for my blower fan to kick on in my either furnace or air handler. And so that way I have all my components operating simultaneously. On air conditioners, the sequence is they all are going to run at the same time, unlike the furnace where it sequences it. So now we look at a heat pump. The only difference here is let's see. So this is in heat mode. Typically, the reversing valve is the only thing we've added to this. If I go and I say, okay, I want heat, then what I'm going to do is I'm going to send a signal to that reversing valve. It's going to slide over. It's going to send that hot refrigerant into my indoor unit. The cooler refrigerant is going to go outside, and I'm going to be able to supply heat using the refrigerant of that system throughout my home. And then in cool mode, only difference is I'm just going to have no power going to that reversing valve from my thermostat. So then it operates in normal air conditioning mode. So we've kind of looked at this from two different perspectives on AC systems. So we have straight AC, usually with a gas furnace, or you could have an air handler with electric heat strips. Most common, I believe, is going to be just the furnace with a coil with an AC condenser. Then your heat pump system are typically going to be mounted with a air handler and also with the auxiliary heat strips. So kind of reviewing kind of what we went over today, we kind of explained the furnace sequence of operation, how that operates, identifying different categories of gas furnaces, and also we described the AC and heat pump operations of these systems. Again, this was a big overview to not get into far as the technicalities from a technician standpoint, but a better understanding of how these systems actually do operate and kind of what we're looking for as home inspectors when we go out on these calls. All right, I'm going to go ahead and turn it back over to Ben.
Hey, thanks, Eric. That was really good. I really like that. And it's really important for home inspectors to understand especially the cycles of the furnace and the air conditioner and the heat pump and how it works, because we're essentially educating our clients, our homeowners. And one of the things we want to do really well is to communicate how the freaking thing works, right? And if we don't know, then we can't communicate that. So having the basics, even for veteran certified master inspectors, is really good. I really appreciate your work in doing that. We do have some questions if you have any time.
Sure, absolutely.
Paul asks, why are furnace and water heater flue pipes oriented to the chimney based on the BTU ratings of the units being serviced, with the highest BTU pipe at the bottom? What happens if they're reversed? So when two, like the water heater and the furnace, come in and they Y up vertically into the chimney stack, why is one on the bottom and the other one on top? How do they orient?
So as far as that goes, and I have seen them out there like that. I honestly don't know the specifics as to why, as far as the BTU ratings and those flue pipes. And typically you'll see those on the either 80% furnace matched up to a natural draft or a induced draft type water heater. But because they both do have the inducer fan motors, as far as that specific configuration, I don't have the answer directly on that, how those tie in.
And it's always the manufacturing recommendations, so
yes.
I was talking about that before. Sometimes I'll just pull it out and see if I can quickly figure out what is going on or not. But I always say, as a home inspector, like if I don't know, I'll just say I don't know, but I'm going to get you the answer. So you can always do that, picture of it and do a little research, and then find somebody who knows the answer and get back to me.
Yep.
So good question, Paul. Lori asks, if I'm inspecting a heat pump, how long should I wait before switching from heat to cool, or vice versa?
Awesome question. So nowadays with systems, what'll happen is you can switch it automatically. The technology built into heat pumps, now they have a 5-minute compressor lockout, so you can't damage the equipment. If you go over there and switch it, it's going to stay off for about 5 minutes before it kicks on. If it is kicking over immediately, once you change it from heating to cooling, then that would also be annotated as something that needs to be checked out by a technician.
Uh, Paul asks, how can you determine if a metering device is bad or in need of replacement? What normally happens?
So that gets a little bit more into the technical aspects, but metering devices can either fail shut or they can fail full open. Inspecting a system without gauges and trying to figure out exactly what's going on, it's going to be very, very difficult, but easy for a technician. But in essence, the biggest problems are you either starve the evaporator, which means now you're not really cooling the house. So that's going to be one indication. The other indication is you flood the compressor. You're sending too much liquid back to that compressor, and over time it is going to damage it. One indication that you can kind of speculate that from an external standpoint, standing outside the unit, is if that compressor is making a horrible noise. Compressors do not compress liquid, and when it tries to, it messes them up. So that would be the biggest indications that you might have a problem with the external or the TXV.
Let's see. Home inspectors, there's one called Micro, operates AC units in the dead of winter without knowing if there is a sump heater or pump heater. What's your opinion, and what at temperatures do you not operate them? We talked about this before. What about turning on an air conditioner in a cold climate in the winter?
It's not going to hurt it. Liquid refrigerant, and we probably all heard it, and I think this is where this comes from, is that oil inside a refrigeration system will migrate to the coldest place. Your evaporator coil on a straight AC is typically your coldest area, so oil does migrate from the compressor through the system and into the evaporator coil. With that said, operating it on the outside, if I can operate it at 0 degrees, and that's if it's warm enough inside to actually get a call for cooling, then I'm making the outside a little bit cooler. And again, that's just going to cause that oil to migrate back to the compressor where it should be in the first place. So it's not going to damage it or hurt that equipment.
Eric, I really appreciate it. I mean, I really do. That was an excellent presentation. And I know it's going to be very valuable for our InterNACHI members and home inspectors. I really appreciate your time and prepping the slides for us and taking a Saturday morning to be with us today.
Oh, absolutely, Ben. And I greatly appreciate you having me on here. I love what I do as far as teaching this.
That's wonderful. Thank you so much again, sir. And I appreciate it. And thanks everybody for attending and watching the video. If you're watching it now, feel free to reach out to NACHI at nachi.org/contact. We're all on the contact page. And Eric, one more question. What about the slides? Folks are asking about the slides. Do you want to make them available? Is that possible?
Yeah, we can definitely do that. If you want, what I'll do is I can get those over to you, and then you can be able to post them and make them available for everyone.
Fantastic. Will you come back sometime?
Oh, absolutely. Just let me know when.
All right, buddy. Thank you so much. Stay safe and healthy, everybody. We'll see you next time. Thank you. Thanks, Eric. See ya.
Thank you. Bye.